Welcome to the Valve Studio. My journey to Tonehenge continues. I've been making a lot of progress. I haven't posted in a while, but I'm going to make a short video tonight to tell you about where I am. And hopefully, not this video, but the next video, we'll actually have a moving machine and we'll show you some aspects of that. But I'll show you where I am right now. For those of you just joining us, I'm using a XAxis 5, which is a Cypress part, using a port from Bart Dring of Gerbil over to that, and I'm building the operator interface onto it, so you don't have to use a computer to drive Gerbil. You can actually do things from a operator interface, you know, a traditional one with a jog wheel, buttons, and reads your Gerbil files, your G-code files right off of an SD card. So I'm going to show you the operator interface. I have it here on the bench, and then I'm also going to show you a couple things on the computer, not too much over there, if even at all. I might just take you out to the workshop and show you. Yeah, let's just do that. Let's just make it really short. I'll do this. I'll go out in the workshop. I'll show you the progress there, and then we'll go ahead and wrap it up. So over here I have my tilt front panel for my operator interface, and I have a jog wheel here. I have a series of buttons. LCD display and 3 LEDs up here to talk about status. There's no LEDs in here yet. And on the back side, what I have is a custom PCB board, which is 100 millimeters by 100 millimeters that I got made over at JLC PCB. Here's the XAxis 5. It's a CY8 kit 059, and it's got a debugger board up here that's on a breakable interface. Here's the back side of my 4x20 LCD display, and I have a analog potentiometer down here that has 2 switches on it. One of them is for the totally off position when you're fully counterclockwise, and it also has a push button interface on it. And then over here I have a SD card reader that I'm pulling in over SPI, and I 3D printed this little fixture to hold this card reader in place. And then inside the real enclosure that I'll show you in a little bit, this is going to mount right on the side of this thing. So let's go ahead and show you what I got. Oh, where's my... I need this for a demo. I need this baby. All right, so I'm going to plug it in. We'll see if the lighting works right. Hopefully it will. Okay, you can read this. Yeah, I had some problems with lighting of this display. I've still got the protective cover on here, so it's going to be a little glary. But basically the outline of these is that this is your axis select button, so here's X, Y, and Z. And then when you press these, it changes the axis that's actually going to move when you twist the jog wheel. This one over here is how far the jog wheel a click is. So I'll just go ahead and show you. So right now I'm on X. Everything is zeroed, and so I'm on X, and I'm on the smallest increment. So every tick is actually 1/100th of a millimeter. Okay. And then if you're on this one, it's actually 1/10 of a millimeter. And then this one's actually, what is this one? This one is an entire millimeter. Okay, so that's these 3 buttons here. This button over here is what I'm calling select. I'll talk about that in a minute. This button here is changes the coordinate system. So we're up here. It says we're G54. We're in millimeters, and currently we're idle. This is our feed rate. We're setting at 0, and this is the value of the feed override. So this knob down here is an analog potentiometer being fed into the XAxis 5, and it varies the feed override. So if your Gerbil, your G-code file calls for, F1000, which is 1,000 millimeters per minute, you can slow it down or speed it up. This bottom line down here is the last line that the Gerbil code actually processed. So as you press these buttons up here, you can see that this display is actually showing you the command. This is a jog command of X 0.01, and a G21 is, what the heck's a G21? G21 is millimeters. G91 is relative to the position we're in, and we're doing it at F750. It's actually F7500, but you can't see that display. That's not important. This is what the last command is. So down here, we're actually doing, we can select between G54, 55, 56, and 57. So I'll get back to, I'll just sit on this one because this one's got kind of different offsets. This button here is millimeters and inches. So when you press this, it switches the whole display, and it also switches all the units over between inches and millimeter and metric. So it also says inch up here. And if you see this little light up here, this little light is a heartbeat light that's telling you that the whole processor is functional. Down here, this button is axis 0. So if you're idle and you're on, like if you're whatever axis you're selected, if you press this button, it's going to 0 that axis. Okay, so I'm on X, I just zeroed X. So if I want to 0 Y, I can 0 Y. Is that right? Oh, I hit the wrong button. This is 0. This one down here is, this one down here turns my spindle on. Okay, so if you look up here, you got M5 or M3. This is toggling M codes between the spindle being on. And also we have an indication over here that says my spindle is on. I got an S right here. This one is my mister. In my case, I'm using an air blaster, compressed air, to blow the chips out of my workpiece. So this one it switches between, I don't remember what it switches between. It doesn't actually send G codes. It switches between M7 and M9, and it turns my air on. And then ultimately, these will be connected up to spindle AC relay to turn my my router on. This one actually is going to open a compressed air valve. Okay, so that's what all these do. The one last thing was this button over here. This button is like a select button. So this lets me select between different either actions. These are like macros in the Gerbil world. Okay, so I have X0, I have home, I have X10, Y10. So these are just little commands, and you pick the one you want by moving the wheel around. And then if you hit this one more time, it goes over to load. So this one is actually load, use feed select, which is this button. And then what it does is it reads off of the SD card. So let me get the SD card back out here. It reads off the SD card, G code, and it actually sends it into Gerbil. So we'll go ahead and, well, I'll show you that in a minute. Or it goes just back to the interface, and then the jog wheel works again. Okay. So this thing works pretty well. This is a really tight jog wheel. I suspect it's going to get looser over time. And I've got this high one actually is set so that it equates out to running about 10 turns of the jog wheel will go over the entire axis of the machine. All right, also have this working. This is based on another project I worked on. That's a PSOC project to actually read in and completely decode the IR signature of these, the pulse train coming out of this remote. This is a RC65 DirecTV remote. I had a bunch of these. I've used them on other projects. These are really incredibly inexpensive. You can get these on eBay for about $5. And I have certain keys on here mapped. So right now I have these buttons over here, up, down, these jog buttons, X minus, X plus, Y minus, and then these two buttons over here are Z. So my IR receiver is right here. It's a hole drilled through here, and if it's between the sandwich of the board and the front panel here. So I'm going to hit the Z up, so you can see that Z is going up. Okay. And it actually runs G1 at a feed rate. So this is now active over here. It looks like my feed. I got a little software bug here, but if I run, I've got the feed down. Let me reboot this thing. Okay, so this number here is the feed, and it is was it a 3-digit, 1, 2, 3, 4-digit number, and then I got this. This is my percentage. So If you go up here, it doesn't increment in tens. It's close enough, 98. So this would be like 100% feed rate. So you can see that I'm going to press the Y, so Y over here is going to change. But it basically runs, and you kind of get a sense of how long it runs. It runs right about a second. And then if I turn it down here to 10%, it takes F 2500 and makes it F basically 250. And so it runs a little bit slower. Okay, so that's kind of cool. The other kind of thing that over here on the select button, these macros are actually sending in commands that actually also adhere to this. Now you end up selecting the macro. You select which one you want to run, but it doesn't execute it until you either press the feed button or you dial it all the way down. Dialing all the way down is really a safe practice, because what it basically does, if we come back over here to here, this feed rate goes down to 10%. Gerbil doesn't like to run. They don't recommend you run lower than a feed override of 10%. So you can't like do one. It kind of messes up the timing pulses, but that's fine. If you turn this knob off, it goes into hold here, so it's not idle anymore, it's off. So the whole machine is in, it's called a mode, it's a state mode. It's a state, actually. It's a Gerbil state of holding. And then you turn it back on and it'll go back to idle. So when you do these feed selects, like say I'm going to do this one down here, so I pick that and I dial it all the way down. It says it's going to send this, but we're in hold, so it's not going to do anything just yet until you turn this knob back on, because we're in hold. So if you turn it back on, it goes ahead and actually runs that command. Okay, so it's really quite flexible in the way it works. And then if you go ahead and turn it up fast, it'll get to its destination. There's a couple other buttons on here. I can switch between units on this guy, between inches and millimeters, using the format button. This button in the middle is the easiest one to, when you pick it up and you put it in your right hand. This button is naturally where your thumb resides, so this one here is the feed hold run cycle. So if you toggle this when you're running, it's the easiest way to stop the machine. So if you're about to have a collision or something, you have an issue, you can go ahead and put it in feed hold with this button. These ones down here do axis select. So the red does X, the green one does Y, and this one does, the yellow one does Z. And so this implementation of Gerbil actually will do four axis. My machine is only a 3-axis machine that I'm putting this on, but this blue button over here on a 4-machine axis will ultimately control the A-axis. Then down here, with these keys here and this, I can actually inject an MDI interface where I can actually type in G-code files directly into Gerbil from here. And a combination of the dash, which is a minus, and enter will actually submit a command right into the Gerbil processor. So this is a really handy thing. It's wireless, and you can move it around. So let's go ahead and run one of these jobs. So I'm going to come back over here and I'm going to pick one of the biggest one on here is the GitHub logo. If you were to find an example of this, it's a G-code file, and it's actually residing over here. So I'm going to go ahead and run it. And remember, I can either dial the feed override down, or I can just hit the select button. So I'm going to put that back up and I'm going to hit select. It says I already loaded it, and here we go. So it's running right now. Turn the spindle on and it's going. Okay, so this is about I'm at 105% now, and the feed rate set to 1016. This is actually came from the G-code file itself. And in any time when I'm actually running, these buttons don't do anything. This is a lockout, so you don't actually inadvertently screw up the running G-code. The only button that works on this thing is this one here. This one actually controls the air valve for my my compressed air to actually turn on the basically the mister, in my case, the compressed air to blow the chips out. Feed override works. I can dial this back down to 10. I can also turn it off, which puts it in hold. Okay. Or on the remote, I can hit this button here, which also puts it in hold. Okay, so this is what I got going in here. And I've also been working on the physical machine. I'll go ahead and show you that now. We'll just go right out to the workshop. Okay, I'm out in the workshop. I'm just going to show you where I am on this the build out here. And so what I have is I have all the both drag chains installed, and I got these quite large ones, so I have a lot of freedom to put more things in here. And I have the both motors of my Y-axis wired up, and so I brought over a 22 gauge 6 conductor cable here, and I actually fed it through I thought I was being pretty clever by feeding it through this piece of this back piece of extrusion, but it turns out if I did it again I wouldn't do this, because you can't take the machine apart after you get it wired up. It's not maintainable by doing it this way. If I build another machine like that, I'm not going to do that. I'm using a terminal strip where I need to. This is a six position terminal strip, and I bring in the stepper signals here, and I also bring in my input voltage here, which in my case can be 36 volts. And then those things are all these signals have to go to this stepper as well as the other one, and then I just have all these wired up here. And over here on the X-axis, I have a drag chain installed back here, and up here I have a USB hub so I can run cameras or some other types of things up on top of near the Z-axis thing. And then I just have all these pigtails that I'm going to cut off and trim, and then down here I'll have access to my I have a 1x12 here, which is going to give me 6 to run the stepper motor, and then I have an additional 6 for other things like like the probe and whatever else I need up here. And then I don't have this wired up yet. This is my X-axis integrated step servo, but I do have some of the wires brought up through the drag chain, and down here I have a 1x8. So it was critical that I do my wiring diagram to get the appropriate size for these, so I don't have to put them in again. And then up here, this is a thing that I've been working on quite some time. This is a 3D printed mount for the back end of my controller. So let me get my controller here. See if I can actually do this without breaking anything. So this is going to kind of sit right here like this. Actually haven't married this up yet. Hold on a minute. I don't want to break anything. That'd be disastrous. All right, here we go. So this isn't helping any. All right, so anyway, this is going to sit like this, and then to stow the whole thing, remember this is going to be on an elevated platform. It's going to go down on my workbench. You'll actually end up swiveling this around like this, and so this whole controller actually fits inside the rectangular space occupied by the machine. And then when you want to use it, you just slide this back out again. And it turns out that this piece down here is, like I said, this is 3D printed, and this is another 3D printed flange, and I'm using a piece of 1-inch PVC here as basically an axle. And right now it's friction fit. It's super stiff, as you can tell. I got to really put some force into it. It'll loosen up over time, but as it loosens up, I actually have provisioned into the design that, I can't even see where I am. Here we go. Provision a set screw in here that is going in and using a nut on the inside of this plastic that I embedded into the collar here, so you can actually tighten that down. And I've also provisioned for 3 M5 holes here so I can get this guy in there. But it turns out this one's so stiff it's not going to move. In fact, I'll probably never get it out. I had to kind of wrench and tap and push and fight to get this one in there, so I'm not too worried about that one. This one will come off, and I do have a lot of pigtail wires here, and I'm going to leave them along because as I did this, I've been listening to the DXF podcast, which is a digital fabrication podcast that a couple of guys that do a lot of desktop CNC work put on. I'll put a show note down there, and I'm at a loss what their actually names are. I should know that, but I don't. So anyway, they talk about actually taking your machine and putting it into a surround to keep the dust collection down. So if I do that, I need this operator interface to be outside of that enclosure, and I can't get a really good seal with its location mounted here. But I did want to get this whole thing running before I get the elevated platform going, because I want to get this going. I'm getting kind of tired of this not running, because I need to wrap this up, because I want to get back to making speaker enclosures. So that's where I am out here. I think that the next time, my next video, I'll be able to go ahead and show you this running. I'll go ahead and do an alignment run. I also have my limit switches mounted here on both sides on all the axis except for Z. Z only has a limit switch when it's fully in the up position, and that little mother, and I don't use that term lightly, that guy is literally impossible to get in here after you've put it all together. I would say I spent at least an hour and a half getting that thing in there. And then down in here, I had to put these zip ties on. This bottom zip tie down here, however I might get my finger in there, that bottom zip tie took forever to get in after I got it assembled. And I just mentioned about the wires being embedded down in the track here. So I have this one. This is my limit switch for that other corner, way over there. And I'm running it through the extrusion. This is a big mistake of mine. I thought I was being clever, but it turns out just a pain in the ass. I should have just run this right underneath this drag chain in this top slot. That's where I should have run it. Because what that did was I can't take this extrusion out. I can't loosen everything up and slide it back out this way. And because I couldn't do that, I couldn't get in here and actually mount the limit switch and all this stuff. So anyway, live and learn. I'll do this better next time. But the rest of it's looking actually pretty good. I plan on having my external power supply like right here, and some solid state relays to turn the spindle on to actuate the air. Some other types of things off to this side, because there's going to be room right here in the overall plan. And then I'm going to leave these long, because I think eventually I'm going to make a plexiglass surround for this whole thing, and move this outside that plexiglass stand, because this is my workshop, and I don't want it to be full of sawdust, which it will be if we're running this machine. I will be doing dust collection, but you know how it goes. All right, let's go back into the lab, and we'll wrap this up. Okay, well, that's where I am. I talked as fast as I could talk, but dang it, I'm still up at the 16 minutes. Anyway, thanks for watching. It's the Valve Studio. Catch you next time.